and my colleague Cynthia Henry and I will run this workshop. And they are workshops. We will have 4 sessions for our workshop, and we will focusing on using R to process data. So basically, to process the research. We are not going to cover general R programming. When I say R programming, I mean using. So we will focus on data processing, analysis, and visualization. So this kind of way, what we're going to cover. The first session that for today, we're going to give a brief introduction to R and R Studio. And we will also talk about vectors, which is the basic data structure in R. And next week, we're going to talk about data frame, which is another R data structure for handling the for handling the tabular data. And then we're going to talk about vector, which is another data structure. And the third week, we will use dplyr and tidyr to for data wrangling. We can create new columns, do some summary.
Thinking. You're not sharing that in the Zoom. Yes.
Okay. Sorry about that. This is the first time I use this lab, so hopefully the technology won't give us trouble. Okay, the last week, the 4th week, we're going to talk about data visualization. We're going to use the ggplot2. dplyr, tidyr, and ggplot2 are all R packages. We will install them together today. And if you're interested in other sessions, you may have to register them one by one. We don't have an option for you to register the entire skill. You should have received my email this morning. It includes links to download R and R Studio as well as installation instructions. You can find all the links on our guide for this workshop.
And I've dropped that in the chat.
This is the guide. So you can see the link to download and the instruction, installation, guidance. And we encourage you to do
Thank you.
we encourage you to install them before the workshop. The email also includes free survey link, which can help us understand your patients better. If you haven't filled out that survey, please do. We are free to install. And if you're attending online, in the email, we suggest how to set up your workspace, depending on how many screens and how many devices you use. And hopefully that will improve your experience with online learning. Today's workshop is 2 hours long, and we will take 5-minute break at around 3 o'clock. And the curriculum we're using is based on the Coventry's course class R for social science. So you can find the link in our guide. You can find it here, related links, course materials. That will be the first chapter. And we open it for slides. If you have any questions, you can use the chat box, unmute yourself, or you just speak. Today we will focus on the basics of R and R Studio, and we will will install our package and we will talk about object in our functions, vectors, and missing data. Hopefully we can cover missing data, otherwise we will start to do that. So R is an open source free data analysis program. It incorporates programming language, which is also called R. So R refers to both the programming language and the software we use to interpret the script written in R. So R Studio is an integrated development environment.
Okay, so while you are installing R or R Studio, I'm going to talk about why we are going to learn or we're going to use R and R Studio. R is free and it is not only free, but open source. Anyone can inspect the source code to see how R works. And because of this transparency, there are less chances for mistakes. So anyone finds a mistake, they can report and fix bugs. So it's cross-platform. We already know we can install R onto Windows, Mac, and also Linux. It's very convenient for people who use multiple systems. And also R has broadly used in many research areas, say biomedical or social sciences. R has over 10,000 packages, which can extend its capabilities. And R also has some packages for specific areas, let's say GIS, geographic information systems, or R have specific packages for bioinformatics. Research reproducibility. So talking about research data or research, we know that reproducibility is important to research and to sciences in general. We see journals retract articles because of irreproducibility. And we can pick, when we pick up tools for research, we want to improve the reproducibility for our research or analysis, allow us to automate and document the analysis process. So R is a scripting language. When we use R to handle data, we have to write scripts. We, instead of kind of mouse clicking or dragging or dropping, the analysis process is written into those scripts. We run the scripts, do data cleansing, analysis, and visualization. But when we collect more data, we can rerun the script. It will redo all those processes. And when we share the data with our co-workers, with our collaborators, they can reproduce the process. R Studio offers some features to improve the reproducibility, and I will walk you through the configuration and project creation to show you how these features improve the reproducibility. If you have already got R or R Studio installed, please use the green check mark under reaction.
It's under reactions now.
Okay.
It was just updated.
If you have any questions, and Cynthia will help you in the breakout room. Go.
Quick question. What does it mean by cross-platform?
Cross-platform, you can run the R on different platforms, let's say different operating systems. on Windows, on Mac, and also on Linux.
Oh, thanks.
Any other questions? So next I'm going to show you where R is and how the R interface looks like. If you're using Windows, you can usually your R is installed under C, your C drive, and you can see program files. And when you scroll down, you can see R is installed here. When you open, you will see if you you installed today or recently, you will see the version 4.2.1. If you're in this lab, that will be 4.2.0. That's just one version before the most recent version. It still works fine. And when you open this folder, you will see a list of folders and files. Usually, the executable file is in the folder bin. And when you open that, you will see r.exe. That's the executable file.
So, are you trying to, show us how to install it? Are you telling us how to install the software?
No, it's not installed. It's already installed. I'm showing you how to run it.
Showing you how to open it.
Can you take it? For me, I have it. I installed it already, and I can access it. So I try to understand what you're trying to do.
Okay.
So this is it.
Oh.
This Art Studio and this.
No, it's not in our studio. It's
yeah,
just.
it's the other one.
Mhm. Yes, but this is could you go to I haven't used a Mac for a long while, so this is Windows. So you can see here your computer, and you have C drive and you have program files, and then here you see R, and then you see the version 4.2.1, and when you click open this folder, and you will see the bin, and the executable file is in.
Excuse me. I already have the art studio. Do I need to do anything like? I have this is our studio. So do I need to do anything or just like?
I'm talking about R. R and R Studio are two different
software?
files,
Okay.
two different programs. So here in the folder bin, you will see the file r.exe. This is the executable file for R. When you double click this file, you will see this kind of black background window. When you click the file, you open and kind of start an R session. You see all the information. It tells you the R version we're currently using is 4.2.1. And it also gives you some information about how to check the license, how to check the contributors, and all the other information. And at the end, you will see greater than character here. And that's a prompt for the R language. And also you see the cursor is flashing, which means R is ready to accept command. You can put your R command here. Let's say we can do a simple calculation. Let's say we can key in 2 + 3, and when we hit enter, we will see the results.
I'm just wondering, I got what she's saying. It's, it's the software.
We're going to show you a few
When I
things here.
open the software, let's do this page.
And also we can print out the famous hello world, use the function print and parenthesis. hello world,
And our studio is where we'll be
and we
most of it.
enter, we will see hello world is printed out.
Oh, can you move the mouse? Cause they can't see. I guess you probably moved the mouse now.
Yeah.
Okay.
Moving the mouse, but it's black.
Okay.
The command window we will not. Any questions? Are you still with me? R is the programming, the software. It interprets the R scripts, and R Studio is an IDE, which kind of setting up the R environment that can help us to use to do our coding in R and offer some tools. So to make the programming process easier and can say enjoyable.
Our studio is just an IDE, right?
Yes, it's just an ID. So to use R Studio, you have to install R.
Yeah, same as Python, like we use different IDE, but it have to be in the program. So our studio is just where we got a better platform to practice our R or work with R. Like it's an environment, right?
Yes. So this is kind of a command line window for R. And according to the instruction here, we can see we can type Q parentheses to quit R. And we just quit. Hit enter, it will ask us save workspace image or not. We press N, mean no, we're not going to save the workspace image, and we hit enter, it will close the window.
Sorry, which will click Y and or C? Save workplace image. Y and or C.
N, we will click N, that's no. Y is yes. And C is cancel.
Say that again in front of my.
Y is yes, and N is no, and C is cancel. So we kind of type N and hit enter. We're not saving any image, and we will quit the R session.
It's not working.
Not working?
No.
You're still in the R session? The Windows is still there?
Yeah. It's just, like and
Hit enter, it will ask you again.
not that.
Oh, that's another line.
Oh yeah, I got it. now.
Okay.
Thank you.
The prompt greater than, that means another command. If you key N, it means N is a command. So, but here it's not.
Got it, got it. Thank you.
So this is a way we kind of open an R session from the command line. And there's another way to so there's another way to open the R session, and we can click, if you're using Windows, you can click the Windows at the bottom, and then you scroll down to R. Yeah, and here you click the R 4.2.1.0, you open this window. This is GUI, the graphical user interface GUI. offered by R. So instead of the black background, we see a white background. The contents looks the same as we just saw from the command line window. And we also see the same prompt and also see the cursor. But on the top of this windows, we saw it is called R console. The same, we can key in commands. Let's try a different one. We can see get WD, that's working directory. We will explain that later. And when you put parentheses there and hit enter, it will show you your current working directory, which for me is under the documents.
Sorry, I cannot see.
Oh,
Oh, switch off the light.
I'll get the lights. You zoom in a bit.
it's not really increase the size of the font.
Oh, I didn't because it's a GUI, I'm sure. Because it's not a real page. I was gonna try to get it.
Oh,
Up
okay.
here. Good. Right, there's the right ones. That might help a little bit. It'll make the front screen glow a little bit better.
Excuse me, I only saw the on console, but I could not see the black one. Because when I.
The black one, you will go click here,
Oh. Or you-
and then you go to this one, and then scroll to the program files, and then scroll down to R. And this one, and bin. And
Choose
run
like
this
where
file.
we are.
That's the original R command line. And to improve the user experience, R built in this kind of geographical user interface. So it's kind of the people kind of coding in R will have a better experience with R. So, and also this geographical interface integrated our script editor. So we can create an R file here. We can enter file and new script. So we can put our code here. Let's say we want to assign a value to a variable A. We key in A, and then we use less than followed with a dash or a minus, and then we assign it say 3. When we hit enter, we did not see anything because we didn't really run this command. If we keep the mouse on the same line and then we press this button, the third one from left and also the third one from right, it's the one in the middle. And we click this button, we will run this command line. And to check the value of A, we can put A there and we can run this line here. Also, if we have the commands in this R editor, we can select multiple command lines and we click this button and it will run the multiple lines together.
Hit enter.
Enter, yes.
Yes, it's running. Say that on the mic, Gigi.
Okay. So you select this, all the commands, multiple lines, and then hit this second or the third button, and it will run the commands together. So the left part, that's the R console, and the right part is an editor. And the difference between these two is in the console, we can run the commands and see the results right away. It is a good place for quick tests, but the code cannot save. In the R editor, we run this code, we run a chunk of our code, the scripts, and then we can save the script as an file, as an R file. We can press this button, the second one, or we can use file and save. It will ask us, let's say, the name of the file. So we can name it test, and then we save it. Next time, when we open this file, we can run it again. This is the script, R script. You can, how do you run? It's not necessary you have space on that. To run it, you can select those lines, and then you click this button, the third one, yes, and it will run here. So that's kind of the difference. When you run the command in our console, you just hit the enter, and when you run in the editor, you have to select and use this button to run them.
So we will do this sort of practice in the R Studio, right? This is just for showing us.
Yeah, this is just showing us the R graphical interface. Yeah, you can open a new script. Yeah. Oh. So it will show you different windows.
Okay. We're like 10 till 3, Jing Jing. Okay. We need to.
I don't think we can finish all the content for today. We will see what we can do.
Okay.
Okay, so we just saw the black background windows, command line windows, and also we see this R console and our editor in the graphical interface. Next, we're going to see the R Studio. So first, we're going to close this. To close that, we can quit R here, on here. We still use the same command Q, and we quit. It will ask us the same question, save workspace image. We can click no. So this is Y and C, yes, no, or cancel. So this time we just use our mouse. So this is kind of the graphic interface instead of we have to key in N. So this time we're going to open R Studio. You can use this search box on the Windows, and you key in R Studio. It's already popped up for me. And open R Studio.
Now you may need to zoom in a little bit here, Jing Jing.
I think I can.
You could, because you did it last semester. Sorry, I didn't mean to put you on the spot.
Okay.
Oh, yeah, there.
Control plus. Okay, control.
Yeah, that works.
Okay. So first we're going to talk talk about the RStudio interface. So we can see it has 3 panes. To the left, we have our console. That's exactly the same one as we just saw. We can key in the commands here. Say we can put, we can assign a value, let's say 5 here. And we hit enter, we can check A is 5. So to the right, it has 2 panes. On the top, we can see environment, history, and other 2 connections and tutorials. We're going to talk about environment. We see we just created a variable. It's called A, and the value is 5. We can see that in the environment. And when we click the history, we see the 2 commands we run. A equals 5, or we assign 5 to A. And at the lower pane to the right, we see files and we see plots and we see all the files. We can see all the files under our working directory. So our working directory, let me see, we can check the working directory. So it is users, that's the documents, and we see the files in documents. And we just save the test.r in documents, we can see it here. And plots will display the plots we created, the visualization we create. We can find one, let's say plot sign. And then we can see this sign curve here. Okay. One thing I forgot to mention is if we key in some incomplete file, incomplete command, let's say I key in 4 minus, and when I hit enter, in the next line, I will see a plus sign, which means your command is not completed and we are waiting for the rest of your command. And when I finish it, it will show me the result. The plus sign means your command is not completed.
So I think people think you're going just a little bit fast. If you'll slow down just a little bit, that would be great.
Okay.
Okay.
Sorry, let me ask you a question. That is, we erroneously enter 4 minus. The
4
command
minus is,
enter.
okay, I want 4 minus something.
Yeah, exactly, but that's something, we didn't put it, so that's an error, right?
Yes.
Assuming you want to go back to that same line, like 4 minus, you want to put 4 minus 3, so you want to include 3. How do we go back to that same line?
No, this one you could not go back to the same line.
Okay.
Jingjing, I think you need to repeat that plus sign error.
Oh, okay. So plus sign, let's say when I key in an incomplete command, let's say whatever, and I hit enter, the R knows it's the incomplete command. It will prompt a plus sign to let me finish this command. So I need to add something, and then I hit enter. When I complete, it will do the calculation and show me the result. There is another way. Let's say you finish the command. If you say, I could not finish the command, I don't know what I'm missing, and you can just press the escape, and you can also jump out. You can start a new command.
I see.
Is that what you're looking for?
Yeah, it's addressed.
Right.
So just, escape if you want to discard the.
You can jump
command.
out. You can just stop. I'm not working on this command anymore. I jump out. Okay, you may notice, let's say when I key in some commands, when I key in the first 3 characters, it will pop up something and I can pick up. So you can use your arrows, up or down arrows to browse the commands. So when you get the one you can see, you can use the tab key to select the first one. Let me do it again. When you key in the first 3 characters of a command, it will show you a list of commands starts with these 3 characters. And let's say, for now, I know I'm going to use get WD, and it's now on the top, and I can use tab to finish the command. I don't have to key in all the letters, all the characters. So we can see RStudio offers a single interface where we can write the code and we can navigate to the files, and also we can inspect variables in the environment, and we can build the blocks, and also it has some shortcuts and it has some auto completion, as I just showed you. That will make the typing kind of easier and less error prone. Comparing with the command line, I think the RStudio, this interface is more user-friendly. So we strongly recommend you use RStudio to create and edit your scripts, especially when you just started to learn R.
How do we save the command?
You save the command, okay. So as we saw in the GUI, RGUI, you can save the file. And you can see this test file is just we saved from our previous practice. And in RStudio, you can also create an R script file, and you can press this button to the left. This button, the first one, and R script, and it will create R script file. And also you can do it from here, files and new file and R script. It will create R script. This is the script editor. You can put your script file here.
Excuse me. How to delete the, how we can delete this, the console, what we have history, if there is any way to remove the history?
Yes, you can. So I think there is, how do you call this, room or at the corner, you see
Yeah,
my
got it.
circle, and you can click here, it will clear everything.
Thank you.
Oh, the room.
Yeah.
Gotcha. You got it. I just didn't see it.
Yeah, it's very light.
Yeah.
So just to clarify, in the top, we will write the code where the R
Yes, you can
script.
put the code there and you can save the scripts.
Yeah, and in the console, we will test, apply.
Yeah, you can test and you will never, you cannot save it, but you can see it here in the history. You can see all the commands running, all the commands wherever you run in from the scripts or from the console, everything you run, other commands you run, you will see from here.
So how do we copy from console to the?
To the scripts,
Yeah, to the script.
okay. Actually, you can just copy, oh, sorry. And then you can just copy and Control C and Control V here. If you want. So next I'm going to show, we talk about the reproducibility. I'm going to show you some R features which improve the research reproducibility. So we know we want to improve the reproducibility. We want to automate and document using scripts rather than the environment. So we want to avoid hidden dependencies in our local environment. We will introduce two concepts. One is, we will introduce two concepts, and also we will talk about 3 good practices. And the first concept we will talk is workspace. We already saw workspace. We already saw that several times. When we quit from the R session using the command line or from the built-in graphic interface, we saw a prompt asking us if we want to save the workspace image. I said no, we key in N or we click no. And that's the time we saw the term workspace. And what is a workspace? When we work in R object we created and loaded will be stored in a memory portion, which is called R space, which is called a workspace. So here we create an object, its value is 5. It is in our environment, it's already in our R memory, that's in our workspace. When we say no to saving the workspace, the R object A is wiped out from the workspace memory. If we say yes, R will save a file. It's called .rdata. Next time, when we open a new R session, the workspace image file will be automatically reloaded. And this automatic reload is default behavior. It sounds amazing, but it's not recommended because if we, it may cause some problems. If we are working on several projects, let's say we can maybe save the environment of project A to or from the project B. Or when we migrate these files to another computer or another folder to continue our work, the location may not have the same environment. And if we share our data, our scripts with our coworkers, they do not have the same environment in their computers. So they could not reproduce our work successfully. So we don't want to save workspace to a file, and we don't want the workspace file to be automatically reloaded the next time when we open an R session. So I will quickly show you what I mean. Let's say when I close this R Studio, it will ask me if we want to save, and I say yes, save. And when I open R Studio, So you will still see A equals 5 in the environment. And when you check A, then you will see A equals 5. So if you give your scripts to a coworker and they may not have A equals 5 in their environment, that may cause some problems, or they won't get the same result as you do. So here we see the file, our data in the files tab. It's just created when I kind of close the RStudio. And also we see another file, it's called .r history. When I click this, and it opens the file, that's the history file we saw here, and so that's the files we run last time. So now I'm going to show you how to kind of prevent the workspace savings and how to prevent the automatic reloading. So go to the tools. Tools and enter global options. And you can see kind of 4 sections. And this one, workspace, that's the one we are looking for. So restore our data into workspace at startup. We uncheck this. And save workspace to this our data file on exit. We says never. Usually I uncheck this too as I'm running demos. So I don't want the students to see the files I worked on. So I uncheck those. And for history, always save history files. That's the history file, r.r history we saw. And we can click OK. It will save the settings. So it restarts. And we did not see the A equals 5 anymore. We won't see them in the environment. When we key in A, we hit enter, it will see it's not found. Any questions? So next concept we're going to talk about is working directory. And the working directory is where R will look for and save files by default. So last time when we saved the text.r, it saves directly under the working directory. And also the R data and R history files are automatically saved under working directory. The current working directory is displayed in the console on the top of the console. It's kind of the title area. And also we can always check it, use that command, get working directory, and we see that. When we code in R, we use relative paths to the working directory. When we change the working directory, relative paths to our code, in our code, let's say, if we have codes reading in some data sets or reading in some source file, when we change the working directory, that relative path will become invalid. RStudio offers a kind of mechanism called RStudio project, which manage our work with this context. So if we work on several projects, RStudio projects manage our work with multiple contexts. So each project well, has its own working directory, workspace, history, and files, which will make each project more self-contained and portable. So using our Studio project to manage our work is the second good practice, or the first part of the second good practice. So now let's create our Studio project. So this is the icon for the our Studio project. You can click here to create a project. This one, the second one. Or you can go under File and New Project. So we are going to pick New Directory as we are doing something new. And then New Project. The directory name will be our project name. As we are going to use the data, it's called Studying African Farmer-led Irrigation. So we will create a folder. It's called SAFI, S-A-F-I. And for me, I want it to be easy to find. I just put it under desktop. You can put it anywhere you want. So this is the directory, the path I want this folder to be under. And then I will click Create Project. So it restarts a new R session. And this time we can see our current working directory is desktop SAFI. And also we can see on the right, SAFI, that's the project name. Top right. And in the Files tab, we see how do you say that? The breadcrumb, and it's under desktop and SAFI. And we see this file .r project. This is SAFI.r project.
You think we'll take a break, or are we gonna plow through?
We may not be able to take break.
Break. Okay,
We will try to see where we can get.
okay.
So if you're working on multiple projects at the same time, when you click on, let's say, okay, so next time when you start working back to this project, you click this R project to get everything back. You can get your history, your working directory, your relevant files in this folder. You can get everything back. So when you always kind of how do I say that? Always open your R project instead of your R script. This is kind of the second part of the good practice. Okay, let me say it again. So the second good practice is using our Studio project to manage your work, and always start an R session with the R project file, with this file. So our next good practice is also related to the research project management. We recommend you to use a consistent folder structure across your projects. In general, our research project contains data sets, scripts for analysis or processing or visualization, and the documents whatever contents you want to describe. So here is recommended structure. this is kind of very self-explanatory. Data is for your raw data. And if you have intermediate data, you can also put in the folder data. And sometimes if you don't always keep a raw data somewhere in the data folder for transparency, for reproducibility. And if you have to do some complicated pre-process, you may want to create intermediate or transitional data sets. You can create a new folder for that, or you can also put it in the data folder. And for output, you can have one folder for data and visualization, that's the figure output, or you can separate them into different folders. And documents and the scripts, yeah, you can. That's for those, your scripts and documents. So sometimes for different projects, you may want to add other directories or subdirectories to meet your needs, specific needs of your projects. But basically, this is kind of like backbone of your working directory. To create a folder to host those files. And in Windows, you can just use your Windows Explorer to create folders, just like you do for any folders you want to create on your computer. Or you can create them using R. Let's say you can create a folder using R command. You can use EIR and create. Now EIR create is on the top. I just use a tab to make that, and then I create a folder called data. I hit enter. We can see we create a folder in the files tab. And also you see those kind of buttons we can use. We can create folder, and this time we will going to create scripts. When you hit enter, you will see scripts. And when you create, let's say, a new file, an R script, you can save your file into this folder, into the scripts folder, and you just save it, and then you specify and the folder, and also for this one, it's session 1, we call that introduction. And when you hit enter, this file is created, and this is our scripts file, and we don't have anything here, so it's 0. So, are you still with me? Or is there any questions?
So we have one in chat. Is like, are data and the scripts inside the Sophie project? You think so?
Yes,
Okay. I would have said they were in the folder
this is in the folder.
in the project.
Okay, in the project. Okay,
Yeah.
So we can see here.
Yes.
My folder is on the desktop. So this is our Starfy folder, and we see this our project file, and we see the data folder, and we see the script folder. We already have the file. And talking about the data, we are going to download the data from the internet, and the data sets we're going to use is Starfy. We already know, and I think we have we can use the command download file, and then we need to specify where the file is. Then I will put the URL in the chat. So you can copy from here and I will put it in my manual. So first I need to specify where the file is. And next, I will say where we want to put it. It will be under data, and this is backslash. And we're going to name it as Sarfi underscore lin.tsv. And also we want to specify the mode of this file. It's WB, which is written in binary. And then we can run this. It will download the file. And when I go back to Sarfi data, we see the CSV file here.
Sorry, can you take it again? I mean, can you repeat this thing again?
Yes, we are using the coursework from and kind of the online coursework, the curriculum. And so they use this file and we're going to use this.
So where we can get the link?
You have to key in.
Oh, you have to key in?
Yes. Oh,
It's not on our LibGuide?
I think we have it somewhere on the list.
Yeah, it's in session 2, is that right?
No, it's not session. Oh, yes, this is the URL. You can copy. Oh, this is the name you call it. You can name it anything.
I already did it. You have to leave it over there if you expect people to copy the link.
Oh, yes.
Yeah,
it
I
has
can't
to
see
be
the-
files. So,
Jing, you have to put it back on the where your script so that we can see the link to copy.
okay, sorry.
Yeah.
Yeah, that's here.
Is
And
it?
the script.
It's kind of highlighted in blue.
No, on our studio. We want to see our studio.
Our studio.
There you go.
Okay,
Thanks.
yes. Can use this. No. I think you. You don't have the folder data here. All you need to create a new folder. It's called data. If you name it, no. I mean, if you name it capitalize, then you need to change this to capitalize. Okay. Then click.
Maybe I will copy the book.
Yes.
Let's see. You.
Yeah.
So let me try changing. You keep going.
I don't think you created a project, but that won't impact that.
Let's see. Yeah, he's gonna continue to help the class and I will come and help you. Okay, let's see what's. You want me to help you look at something? Yeah. I can't see your script.
So next, we're going to install packages together. The package we're going to use, we mentioned IR, tidyr, and
It's capitalized.
oh, you did block 2. They are all packages under collection of package, which is called tidyverse. So now we can install the package tidyverse. To install a package, we will use the command install.packages. Actually, there are 2 ways to do that. Tidyverse.
Okay.
It's not downloading.
And there's another way. You can hit enter and start the installation. And another way is hit the packages tab and then you click install and put tidyverse here. Make sure you check the install dependencies
Did the HP.
and
Could you help with quotes here, not at the beginning?
it will start the installation process.
That's gonna be removed.
All the packages in this kind of umbrella tidyverse will be installed. It may take a couple minutes to get the installation done.
Okay, so hold on just a second. She's grabbing all those packages, so. Yeah, hold on. Maybe we need to go back so we can see the script when you get that done. Can you scooch it back up? Because the whole class here cannot get the script to load. But I think chat's doing well. When I left chat, they looked like they were doing okay.
Okay.
So this right here, this has to be typed exactly the same unless you've changed anything. Like if you made the data file capital D, then you may have to make it capital D. Otherwise, it should be typed exactly the same. The quotes have to be outside the HTTPS. How are you doing? Why don't you? And then copy this right here. Okay.
Oh, I think you have to end the code.
Are y'all doing back here? Good. Good. Are y'all doing good?
Not finish the code.
No. Okay. Let's see here. Oh, it's a single. Oh, and you have to tell it where to go. So you're trying to get it to download, but not telling it where to go. That's where you have to add the comma with the D, the data. You want to go to the data file, Suffolk.clean.csv, and then that's the mode. So this has to be copied here,
Can always use.
but everything that's blue, you have to copy everything blue on that screen and put it down here. It looks good. Let me see what we got. Oh, sorry, you're right. Oh, this number is not right. Where'd you get that number? It's 11492. Oh, not the survey results either. Let's see. You need to, I don't know where you got the link. So scoot back to articles and then do, yeah, scoot more until that, and then do files, backslash. Oh. Oh, and then the data has to be quotes. See, the first set of data doesn't have quotes. Okay, now I think you should be good. Not do that, no. That cannot have a quote. See, look, there in the D has a quote, but then the rest of the line only has a quote to this. And then you should be good.
It's right here, so it's wrong.
Okay.
So it's already created here.
It doesn't matter.
And then
Oh, yeah.
enter.
So now I can press.
Okay,
Now,
I know
so
what.
This line look the same as that blue line? It does not. You have to go, you have to put this like this. See, data quotes with the data slash.
So the reason is.
So you're trying to tell it where to go.
Enter the.
Wait, no.
Directly.
Try again. Let's just,
This is kind of the word.
now, let's copy that, put it down there. So you have to say, yeah, the whole blue line. No, that's the wrong line. Where did y'all get that file? That's the wrong file. Oh, it's here, this file.
And this is your.
Yeah, that's okay.
But this did not say.
Oh, you're helping him get to the next day. Thank you. I'm sorry, I stepped on your toes. Okay, yeah. Yes. Okay, quotes. Quotes.
Yes.
Yes. No, it doesn't matter. Just be consistent. You have to use the same quotes. Now put the link. How are you doing?
Yeah, I couldn't download actually. You know, I type in the command, but couldn't download.
Okay, I'm coming. And then you have to say, no, so this quote has to stay with this line. And the quotes have to be within the commas. So this, now space,
Yeah.
no.
Yeah,
Put the quote next to the number. Now go on the other side of the quote.
I just want to.
Now push a space. Now push a comma. Now push quotes. Now push data. Backslash. You see backslash Sophie clean? You help him load his? Get him to copy that line. Okay. How are you doing now?
Working directory is Sophie, and this is.
This link. That's the second link, not the first link. Okay.
I have to download this.
They will automatically download.
It will, yeah, you don't have to download it. You just have to type it in there, right? Oh, is it
Just
downloaded?
It's already downloaded.
Now go back to your script. Now copy. over
Can you
and
tell us
insert
again
that.
which packages we need to download? So we will download the base and what else?
Okay, the package we are going to download is tidyverse. We are going to install that
This is
tidyverse.
all right. Just copy.
You can key in the commands like this, install package and put tidyverse in the quotes and in the parentheses. Or you can install from here, package install, and you key in tidyverse here. And then make sure the install if dependencies is checked, and then click install, it will install. And when it's done,
We did it. I did it.
Excuse me, I think
You need to do tidyverse install packages.
so this is install packages. Tidyverse.
How are you doing?
Can I change the data back to the lowercase? I want to change the name of the.
Yes, you can change it here, just like,
Let me ask.
yes, you can just rename it. You can double click.
Oh, good. So we have a question in the chat. Jing Jing, maybe you can answer that. Does install.packages make sure that various packages of different versions don't conflict with the others?
Okay, if you're currently, usually.
It's way at the top. I mean, it's way back up as Andy, like at 332. Oh, it's, never mind, it's direct to me. Sorry. So let me try again. Does install.packages make sure that various packages of different versions don't conflict with each other? That's the question, Jean. You're not gonna be able to see it. It's only to me.
Oh, okay, so, I don't know how to answer this question. Usually, we won't recommend you install too many packages. And you install packages for your specific projects. So we don't expect people to install a lot of packages and they don't use.
So what other packages we need other than Tidyverse? Do you need anything else?
Tidyverse is a collection of packages.
Okay.
So it will include, you already have all the packages we are going to use installed.
Okay, got it.
So this is kind of the contents of the first hour, and
Let's kind of double check with chat too. How is everybody doing? I think we still have one person that was kind of lost in there. But if everybody's kind of doing good, they got the tidyverse added, do a thumbs up in room and online if we're good. We're good?
okay.
Okay. Yeah, all right, I think we're good. And then I'll help the one person, that's fine.
Okay. Okay, so it's kind of a quick wrap up of what we covered the first hour. And we saw the three different interfaces. The black background one is the command line, and the second one at the here is the GUI interface, the graphic interface offered by R. And this one, the last one, is the interface from RStudio. And so RStudio also have features to improve the computational reproducibility. We check the global settings of the workspace. It's under tools, and also we create our project in the RStudio project to manage our project, and see a recommended working directory structure. And we also install the package. We saw two different ways. One is using the commands install.package, and also another one is we can install the package directly using the package tab. So next, we're going to kind of talk about the object in R. What is an object in R, or in this workshop serial? We can understand R objects as variables. In many other programming languages, we will use objects and variables interchangeable in our workshop. We will see more object examples. So, but this time we are going to use the script editor instead of the console. So let's say the first example we are going to see is converting the kilograms to pounds. We know that a value in pounds is kind of roughly 2 times of the value in kilograms. So we create a variable which is called kilogram to PDS pounds. And we assign the value to this. To run the command line in the editor, we cannot simply hit the enter key. We will use control enter. So we can see the command is running in the console. And we also see the new object is created in the environment. This command line, we call that assignment statement, or we can read it as assign to this KG2PDS object. The operator, we call that assignment operator, we use is not equals, is the kind of less than followed with minus or dash. This is an old tradition, as R is a kind of old language. It originates from another language S. So we just follow the old tradition. And also, the advantage of using this sign instead of equals, it shows the direction. We assign the value from right to the left. And in RStudio, we can use a shortcut that is Alt minus or Alt dash. If you're using Mac, I think that's Option minus or Option dash.
So I have it over here.
Okay, just a second.
Excuse me, is the direction from right to left here in this example?
No, it's not. It's not an example. What do you mean an example? This is
It's about that sign shows the direction.
yes, it's just I show the
Yeah.
direction.
So how can you understand is from right
How
to
do you
left
get
or
what that
left
introduction?
to
She
right?
just named.
No, it's
labeled
from
it.
right to
Oh,
left.
All
It's
all the way.
All the way. It's assigned value two on the right to the left object. You could not use the one and then another direction.
No, so it's always from right.
It's always from right to left.
What is the?
And what is from? Oh, you need to type down here. Here.
So now we can try some
Yeah,
kind of
like this.
conversion. Let's say
And then
we
we'll
have
show it.
something weight
Here.
is 4 kilograms. We want to see how many pounds does it weigh. So we create another object which called weight in
Less
pounds.
than.
And we use the pounds minus and kg 2 pounds, and we just mentioned that's 4 kilograms. So
Now you can type here what she's doing.
and
See the weight and
enter.
the next line, number 1.
So when we want to check the results, we can key in the object name and then control enter. We will see the result displayed here in the console. Actually, pounds and kilograms, their conversion is, let's say, 1 kilogram equals to more than 2 pounds. It's kind of, we can say 2.2. We say our current setting is not accurate. To make it better, we can reassign. We can change the value to 2.2. Then we can hit enter. Now we know this value is 2. Oh, no, sorry, I did not run this command line. And then again, this one. So we can see this kilogram 2 pounds. The value is 2.2. We override the previous value. Even we updated the value from 2 to 2.2, the weights, as we have not redo the calculation, the weight, the weights in pounds keep the same. So it's still 8. only after we run this calculation again and check the data, we can see it's updated to 8.8. So from this exercise, we can see first, when we overwrite a value, we won't get any notification, we won't see any warning. It will overwrite right away.
So we can always change the value of any variable.
Yes, you can always change, and you won't get any notification. If you overwrite a file, it will ask you, do you want to overwrite the file? It will notify you, but here, when you overwrite an object, it won't notify you, it won't give you any warning message. And even we update the value, the one object, the calculations using that object won't be updated until you redo the calculation. So next we're going to we create kind of two objects. We're going to talk about the naming conventions of this object. So one is we cannot start object name with a number. It has to start with the letter, a character, or I think it can start with an underscore, but yeah. And we cannot use reserved words. What are reserved words? Let's say if is reserved words, else is reserved words, or is reserved words. But how can I tell if when you key in a word, it becomes blue? That's kind of a feature of RStudio. It kind of reminds you this is a reserved word. And you can use this help tab and you key in reserved, and it will list reserved words here. And always avoid existing functions and variables if you don't really mean to override. And try to avoid dots. That's what I think.
Why?
You may have remember when we install a package, we use install. It has a dot in the function, and when we create a folder, we use dir.create. It has a dot in the function. In R, dots have some special meanings, so we try to avoid them. And the variables are case sensitive. So the suggestion is use lower cases. So that will be easy to read, and also you won't mess up with those. And try to make your object name meaningful. And sometimes we may not be able to use one word to express the meaning of this object. And you can use several words and use the underscore as separators. And usually we use nouns for variable names and use the verbs for function names.
And it's helpful if those make sense not only to you, but to other people, so that if you're sending your data to somebody else and they're going to replicate it, then they understand what that label means.
It will help your coworkers to understand your code easier, and also it helps you, your future self, understands your coding. So to increase the readability of your code, generally speaking, all the programming languages allow programmers to include comments in their code. In R, we use hashtag for comments to comment out. Anything right to the hashtag will be commented out. So let's say here we want to say convert kilogram to pounds. And when we run this command, anything right to the hashtag will be marked. And also we can add some comments to help us understand this file. We can say title and we can call that introduction. And also we can have author. And today's date. So these two lines has not been commented out. And to comment out multiple lines, we can use a shortcut. It's Control Shift and C. You select these two lines or multiple lines, and then you use Control Shift C. That will comment out all your selection. RStudio offers many shortcuts, and to see all of them, you can use, I think
It's Shift Alt K.
Yeah. Alt, ALT, and K. If you're using Mac, that's Option.
Yeah, why don't you show the run one here, because I think people were asking about that in the chat. Like the execute ones down or below this, if you scroll down this a bit, Jing Jing. No, I mean on the thing.
Okay.
Yeah, and so
This is the assign, is there assignment? Is that the one?
no, the run, if you keep going down a little bit, you'll see under execute. I think it's like control and enter will run the one line, and then you control all. Let's see. I saw it on my screen. Yeah, Control Alt R will run the whole code. So,
Okay.
and so Jing Jing uses that often. They could hear you typing it, but they couldn't see. Like, how is she doing that? So that's why.
Alt enter. Oh no, it's run.
No, so if you want to do a single line, it is Control Enter. And if you want to do all the code, is Control Alt R. Or selected lines. I shouldn't say a single line, selected lines, yeah.
Control enter is here and Control Alt R, that's run all.
And that's what you do often, right? Control Enter, yeah. That's what people were asking in chat, like, what is she doing?
And also, sometimes when our code is running very long, it's difficult to read, and we want to break them down into sections. So let's say we want to call this section how can I say that? Object, and we add dash or minus. We add at least 4. That will make this section foldable. You can always open and fold it. So our next section will be functions and their arguments. I can use another shortcut. I think that's Control Shift R. So it just pops up a section. You can input your section label here. So next one will be functions. And their arguments, and when you hit enter, you create a new section, and we don't have anything here, but still you can see it's foldable. So I think it's almost 4 o'clock now. I'm sorry about those technical problems we ran into today, and we will start from functions and their arguments next time. And to kind of quit, and you can just close it, or at first you need to save this file. Save your file that will be under your working directory in the scripts. This is the one. And you can close the RStudio.
How to save the script, like,
Yeah, we can continue with this.
Oh. I cannot see.
So when you start to quit, it should say you want to save and you label the file as introductory or whatever you want to label it.
that's the file, but what if I want to just save the script?
Okay, you want to save this script?
Yeah.
Yeah, you can just click here. There is a save button. Here it's already saved. So next time we will continue with this, and I think I will send you the files I have in my computer. Any questions, you can contact us, and we have a evaluation form. And it is
I got it, Gigi,
okay.
but y'all need it too.
Okay, the evaluation form is in the guide, and the second one has the workshop evaluation.
So everybody that is standing up and milling about, you need to fill out the evaluation, the second link in the guide. If you can do that at some point in the next week, we appreciate it.
All right.